Hello, my name is Oh Hyun Taek, and I will start briefing about our task 4 made by our group 7. The task was to find this angle of rotation and the shear stress, not shear, it's shear stress. Oh, for each shaft number 1 to n. These given properties are force is torque applied to each shaft T1 to Tn and polar moment I1 to In and shear moment length and radius. This is defining force material deformation, equilibrium condition, and deformation condition. The solution is we consider this twist of angle of rotation. How to draw? This shaft, each angle of rotation like pi 1 and this angle of rotation pi 2 and we considered T1 to Tn. In this page, this Tn is not the torsion applied to each shaft. We consider the torque applied to real torque working on each shaft Tn, and this torque is found by, we couldn't find torque just by T1 to Tn given, so we needed to define certain properties here. So this, I'll consider real torque Tn and apply torque to Tn prime. So this torque T1 prime. So we found this T1 by just let's say this torque applied to this wall T0, then this shaft T1 would be like T1 and this couple force also T1. No, T0 prime, and this would be also T0 prime. So the real torque that is applied to this shaft would be T0. So T0 prime. So T1 would be T0 prime. And this, and now we found the T1, so we should finding T2, T3 to Tn. So since we found this T0 prime, And let's see what's T2. So this is T0 prime that's working on T1. And there is also applied force T1 prime. And there would also be couple force same size as T0 prime and T1 prime. And this torque, real torque working on this shaft number 2 would be T0 plus T1. And now we know that if it keep going on like this, Tn, oh, this is Tn would be summation of Tn, oh no, Tn minus 1 prime, and goes in from 1 to, and yes, and this is the real torque that is applied to shaft number. And now using this equation, twist of angle is G1 I1, no, T1 L1 divided by G1 I1, T2 L2 divided by G2 I2. So we can easily find this twist of angle. And also torsion, yes, no, this shear stress tau can be found by this equation. And using Excel, we could find these properties. We put in certain properties to find this twist of angle and the shear stress. And we put just torsion, just any torsion, 1000, 2002, like this. And this total torsion should be T, right? This would be T, and no, this, this is the torque applied to this. Yes, this would be Tn, and yes, this would be Tn. So like all these torque plus T torque 0 that I mentioned earlier, summation of this should be 0, since the total portion, this summation of these have to be 0, so we can find what T0 is. So we can find all other properties like this shear stress and twist of angle of rotation. So this is how we calculated the angle of rotation and torsion. No, not torsion. This shear stress by given such properties. Thanks for listening. Thanks for listening. It's not over tonight.